Okay, ladies and gentlemen, we're continuing here with it's actually a continuation of section 1.2 from your book. I call it 1.2 part 2, but it goes with supplement B1 that the department created. And on that handout B1 that you printed off of Course Compass, you looked under the supplements icon and you printed the B1 handout. Question number 9 asks you to find the domain of this function. H of x equals the absolute value of x plus 3. And question number 10 asks you to find the domain of 3 divided by the absolute value of x minus 2. Now let's start with the simple one. This is not a polynomial function because the absolute value part does, complicate things a little bit. And it's also not a rational function because you don't have the ratio of two polynomial functions. So let's just kind of dig into this one. If I want to know what the domain is, what that's asking me is what x values can I put in? So picture the real number line in your head, okay? You've got positive real numbers, you've got negative real numbers, and you've got the real number 0. Just pick a random positive number. Put it in here, add 3, and take its absolute value, and do you get an answer? Sure. Now take 0. Put in a 0. If you put in a 0, you have 3 in here, absolute value of 3 is 3, so you get an answer. Now take any negative number you want to. Any negative real number you want to. Put it in here, add 3, take its absolute value, and you get an answer. So anything we put in, we came out with a valid answer. So the absolute value function's not very picky. The domain is the domain is the set of all real numbers, because any real number we pick, we are allowed to go in here, add 3, take its absolute value, and we get a valid real number answer. So not very picky. Now, what a lot of times students say is, okay, so anytime I see absolute value, I know the answer for domain is going to be all real numbers. Well, almost always. Number 10 is the exception. I have an absolute value function here, correct? Okay, but the problem is, look where the absolute value function is sitting. It's in a denominator. And what have we already agreed a denominator should never become, right? So this is, you need to kind of synthesize. This is not just one single problem. So some of my students that have asked me, they said, okay, so anytime we see absolute value, do we always put all real numbers? And my answer to them is almost always. Here's the exception. If the absolute value you're dealing with is in the denominator, there's one thing you need to be careful about. State restricted values. What would the restricted value here be? Well, hopefully without an awful lot of work, you can see that the restricted value would be x cannot equal 2. All right? Because if you put in a 2, you would be taking the absolute value of 0, which is 0. You would be causing division by 0, which is not allowed. So, when you have an absolute value function, if it's in the denominator, you need to state restrictions. In this case, x cannot equal 2. Draw your number line, which goes from negative infinity to positive infinity. But when you find the number 2 here, you're going to throw it out by putting an open circle on it. That throws it away. Everything else stays. In other words, these numbers don't cause me a problem, so they are part of my domain. And now I have 2 regions here from the number line that I can use. I can go from negative infinity to 2. Please put a paren, because if you put a bracket, you would be telling me bracket means I can use 2, and you just told me I can't. You're hopping to another section. In interval notation, you put a union. That's for the word or. But in interval notation, the word or is going to become union. And this portion is going to be written 2 to infinity. So this is my answer for domain. It's not all real numbers. It's all real numbers except 2. And this is how you're going to write it using interval notation. So in general, an absolute value function is going to have the domain of all real numbers if it just, appears in the numerator. But the minute you throw it in the denominator, you have to remember to throw in or state restricted values as well. So this is not just an absolute value problem. This is a combination problem of absolute value and the same issue we had with rational functions. And we're done.